Okay, so today we're going to be talking about the microcontroller that we'll be using in class. This device here is part of what we'll call the Arduino ecosystem, which is a development environment and a series of microcontrollers that are compatible with them. But often we just call the board an Arduino. This particular board is called the Arduino Uno. This is the branded one. These run about $20 to $30. The design is open source and anyone can produce them, and so you can get non-branded ones for anywhere from maybe like $3 to $5 online. And just a couple of notes about what's going on here. So there's a lot of different things you could see on this board. This right here is the brains of it, the microcontroller. This is an Atmega 328P. And one of the primary uses it has is just in devices like this where we're using it with the Arduino programmer. But you could use this in like a production, you might find something like this, or at least a different package, like they have different like pin arrangements and different layouts and stuff, and you might find a version of this in some type of commercial product. But if we're looking around here, so we have lots of stuff on this board. We have a USB connector right here that transmits data to the microcontroller and back as well. We have an option for DC power right here. This right here is a voltage converter to take our input voltage and drop it down to the 5 volts for the chip here. This right here is a crystal oscillator, and so it's used for timing. We have this chip right here is a device that basically allows for the USB communication. Okay, otherwise you can bypass the USB and you can actually do programming through these breakouts right here. And then we have a reset button right here, which stops the program and starts it from the beginning. It's connected to this reset pin right here, and so you can also do a reset through this pin here. Speaking of which, you can see on this microcontroller it has all of these legs on both sides, and those legs are connected through traces in this board to these pin connectors on the sides, and those are basically how you access the different pins on this microcontroller. And this is where you start to have a lot of power, and one of the things that's really cool about working with Arduino or other embedded type systems where you have the power to control what each of these pins do using code and using this board or using this microcontroller. So each of these pins connects to one of those things. It can use them to send out information, or it can use them to bring in information. So you can connect them as outputs or as inputs or as both, depending. And then each of the pins also has multiple ways that it could be used. Okay. So we'll go ahead and switch over to another screen here. And so this right here is a diagram that shows all the pins and what their different uses are. And so you can see that each of these pins has a bunch of different labels here. It can be used for different things. Our primary label is as the D, the ones labeled with the D here is just to use it as like an input or output, or digital pin is what we'll call them. And we'll get into more of this stuff later. But we have kind of a built-in LED right here that will blink. You have these two LEDs right here that blink when you program it. They're actually connected here to pin 0 and 1, which you can see here are connected to the UART. And what's going on here is that they're connected to the USB here. And so when we're doing communication over the USB, it's doing it through these two pins. So pin 0 and 1, if we look back at this image here, the pin 0 and 1 right here, we want to avoid using them in our projects when possible, because basically it can interfere with the communication there, and we can get some weird results that we're not expecting just because we're doing communication there. Okay, let's see what else we got here. We have some analog inputs. We'll talk about analog inputs later. These can be used as analog inputs or digital inputs. We have these two down here. Specifically can be used for a type of communication called I2C. And then we have these 4 pins here can be used for a type of communication called SPI. And again, we'll talk all about that stuff later. And then finally we have some of these pins that have like a little squiggly line next to them, and those ones have a special purpose they can have as well for when we're using them to control something that we have to switch on and off really fast. When we're powering the board, we can power it through the USB here, and so a USB port is producing 5 volts, and so you can only power with 5 volts through here. You can also directly power with 5 volts through this pin right here. Okay, or if you're powering from the wall adapter, I think you could do maybe like 7 to 12 or 7 to 16, maybe even 20 volts through here, and then this voltage regulator is going to drop that voltage down to 5 volts for the board. But if you are powering through here with a higher voltage, you can actually access that higher voltage right here through this VN pin. If you're doing that, you got to be very careful, because you don't want to put anything greater than 5 volts across any of these other pins, because you could do damage to the board. Also, if you kind of like connect the 5 volt and the ground together accidentally and short out the board, that's really bad. Generally there's some protections built in to avoid damage, but what you'll see is that these lights that are normally on, like this one right here that shows the board being on, this will go out when you short out the board. And so if you see this light turn on off, you just want to unplug everything, and then you can take a minute to figure out why it got shorted out. Okay? One last thing to show you here. I'll show you one more little display. And so this image is of the pinout for the Atmega 328. As I said, this is the microcontroller on the Arduino. We won't get too much into this, but let's say that you were wanting to use this in like a project that you're gonna put in some type of device, and so then you would be actually looking at this diagram that shows the pinout for the Atmega 328, and you have different purposes for all these pins, and you can kind of see some connections to like which ones are which on the Arduino. Like you have the PWM pins here, you have some analog pins right here, the 0 through 5 analog pins, you have the voltage, the ground, the reset right there, you have the 2 transmission pin, the ones that we're using to communicate right here, etc. So anyway, we won't be really using this at all, but just something interesting to see. So yeah, that's the introduction to the Arduino. So we'll get into programming it and learning how to use the inputs and the outputs, and it's kind of like a blank slate. You can use it to do whatever you can imagine. There's millions and millions of different projects that people have done with these boards, and there's lots of different ways that you can use this collection of inputs and outputs to do whatever you come up with. So I'm looking forward to seeing what we come up with this year in class.